Hello, everyone. Thank you for joining in. My name is Bruce Snell with Qwiet AI. Today, we're going to be talking with Arun and Chris about how we're using reachability and exploitability to really optimize your AppSec program. So, before we get into this, I want to pass it over for introductions, Arun and Chris. So, let's start with Chris. Can you give us a quick introduction of who you are and what you do?
Sure. Thanks, Bruce. And hi, everybody. My name is Chris Hatter. I joined Qwiet in November. I'm Qwiet's Chief Information Security Officer. I also lead customer success. I came over from Nielsen, where I was the global CISO for 7 years. So I spent a large part of my role over there building product security teams, having some success, but also having some failures and learning along the way.
Hi, Arun Balakrishnan, VP of Products here at Qwiet. Been with the company a little over 4 years. My career has always been in security, different forms of it, everything from endpoint to server security to web application firewalls and now application security. And my previous experiences are at companies like Symantec and Imperva.
Great, thank you. And very quickly, I'm Bruce Snell. Been with Qwiet since about November of this past year. My background is more traditionally on the cybersecurity side, from an implementation and consulting perspective. So I'm really here to help kind of drive this conversation forward. And I think today, really the topic is looking into the concepts of reachability and exploitability, explore a little bit about what they are, and then more importantly, how do we take these concepts and actually programize those and put them and make them part of your overall AppSec program? So I think we've got a lot of good content here. So let's go ahead and dig right in. So Arun, I'll kick it over to you to kind of start off.
Thanks, Bruce. So before we get into what exactly reachability and exploitability means and how it could help, what Chris and I wanted to set the stage on is why do we even need to care about those aspects of AppSec? Right? Like, what is a problem that we are trying to solve for? So when we were looking at the research that we have done within the organization, research from various other organizations like OASP and NIST, etc., we saw a pattern, and that's how we determined how to build those features into the product. And so let's go through what that thinking was. Now, when we look at open source packages in general, why do we care a lot about it, right? Why is there so much noise about vulnerabilities in open source? In our experience with our customers and looking at external research, what we see is over 90% of enterprise applications use some form of open source dependencies. And when they do, on an app, on average, there's 60 plus dependencies. Right? Now, when you have 60 plus dependencies and then transitive dependencies on top of it, yes, a big majority of applications are constituted of open source code. Chris, in your experience at previous organizations and talking to your peers, does this resonate well in what you're seeing in those organizations?
Yeah, this tracks. I think it's increasingly true as we build more modern infrastructure, modern applications. I think that number is going to go to basically 100% of the new applications or close to it have open source dependencies. And this is just commonplace now. Most software engineers are quite reliant on the open source community, and honestly, it provides them with the ability to move with pace and move with velocity in new and different ways. So definitely tracks.
Awesome. Right. So now that we know most applications have open source code, and once you start introducing open source dependencies, that brings with it a lot of frameworks and libraries. So it's not just one library, it would have its own dependencies, and you end up with a lot of open source code in your app. Now, why that matters is now all of this open source code, obviously it's code, somebody's written it. It could have issues, it could have vulnerabilities. And most tools out there would look at it and start crying wolf. Now, by crying wolf, we mean is there's a lot of noise out there. Right? It's a lot of findings. And in the previous slide, we said 60 dependencies. Now, each of those dependencies, if they had a handful of findings, multiply that by 60, multiply that by all the transitive dependencies. Suddenly, on day one, you're looking at thousands of findings per application to go and look at.
Arun, unpack that just a little bit. Is it, for the audience, I mean, is the noise created by simply creating a software bill of materials and just comparing that to vulnerability databases without any incremental context over and above? What's driving it?
Definitely, yeah. So how most tools out in the market work is you first create a bill of materials, right? So a bill of materials is saying, hey, this is my nutrition label or ingredient list of what I am consuming. And then for each of those items in the bill of materials, yes, there is a database of known vulnerabilities as of right now. And it's simply looking up against that database and saying, okay, now your application potentially has all of these vulnerabilities. And then hence it's a lot of noise.
Well, and it's interesting that you talk about all of the dependencies and kind of that software bill of materials, right? And that's, I think it's a little bit of a double-edged sword, right? Because there's been a lot more attention to the SBOM over the last couple of years, as we start looking at supply chain issues, et cetera. So I think, I almost feel like sometimes some of these security tools that are being used to kind of do this SEA analysis are really kind of bleeding over from, just trying to produce you a software bill of materials. And they're kind of taking the shortcut of saying, okay, here's the list. And so based on this list, here's what your probable, vulnerabilities are versus actually digging in and doing some real work.
Yeah, I think probable is the key word that you mentioned there. I think
Yeah.
we'll see that unpacked here.
Definitely, right? So now tools create a lot of noise. Now, what happens is most enterprise applications, and this also is a trend that is picking up, and we'll confirm with Chris, what we see in our customer base is, say, looking at 3 years back to where they are today, increasingly more applications are deployed much more frequently. Right? What was monthly is becoming weekly, what was weekly is becoming daily, and even multiple times a day. But at the same time, the same organizations tell us it takes anywhere north of 90 days on average to fix a vulnerability. Right? So now if you put these two together, I mean, yes, vulnerable applications are getting pushed to prod, or at least quote unquote vulnerable applications. Chris, I mean, is this also resonating with you in terms of how often applications are pushed and how long it takes to fix?
Yeah, similar to the previous page, I think in a year, 2 years, this 60% is going to be north of probably 80%. And it's going to keep increasing from there. The 90 plus days to fix a vulnerability on average, I would say that this is particularly true the older or more legacy your application is. So this is on average, but it's easily north of this if you're talking about something that's been ring fenced or is not being actively worked on over the last several years. I think people have a tendency in more modern engineering to be iterating faster than the legacy platforms. And in any organization that's large, global, multinational, that's been around for a while, you have a big blend of a lot of legacy, a lot of old software combined with kind of newer, more modernly developed applications, which could have, a shorter average to fix a vulnerability just because of its level of flexibility. But 90, I think, is a solid average. It's what we're seeing.
Well, and I think that 90 gets pushed up, right? Because you'll have the vulnerabilities that require, the only fix is really to do a package upgrade, right? Or an update to a more modern package, which potentially breaks dependencies within your application, right? So I think you've got the very quick fixes that can happen, but then you've got these other ones that just take forever because they're waiting on, more updates down the line. So it's like this, kind of chain of dependencies that have to be updated for that update to actually take place.
And funny enough, when any tool reports to you that you have to upgrade a package or go to a new version, it's very simple to say that. It's a lot more complicated to actually do it, especially when you think about something like JBoss, Apache, like web servers that are kind of tightly integrated with the application itself. It's a lot harder than just kind of clicking the upgrade button sometimes, and that can really push the average up.
Well, that's why we're still seeing Log4j all over the place.
Absolutely.
Definitely. Yeah. Upgrading from version 1.2 to 1.3 on paper sounds easy. Yeah. It's a lot of work, and anything that touches the application, of course, has to go through an entire QA phase, has to ensure that nothing has broken, all the functionality is backward compatible. So there's a lot more to than just changing a version number.
I think it's the equivalent from like the infosec side of somebody just saying, "Oh, we'll just punch a hole in the firewall." Right? It sounds easy on paper, but there's a lot of steps that have to be done in order to actually do it.
Okay, so what we have seen is, yes, increasingly applications are using open source. Open source libraries have vulnerabilities, and when applications are deployed so frequently and it takes quite a lot of time to upgrade those packages and fix those findings, applications do get pushed to prod even if they have known issues, right? So you have a lot of noise, but you're not able to keep up with the noise. Now, where we want to bring in that kind of a paradigm shift in thinking is looking at all of our customers, all of the findings over the last so many years. What we see is over 95% of open source findings, vulnerabilities, are not reachable. Right? We will cover in detail as to what reachability is and how we define it. But that is where we start the discussion, right? So when you say, okay, you've got noise, but let's say 95% of that, we can park it for now. Let's focus on that 5%. Suddenly you are looking at something that is manageable and becomes more of a something that fits in your model. Chris, anything to add on to this?
Yeah, I would just say that as we go through the next couple pages, most organizations out there, I wouldn't say all. There's certainly organizations that are super mature and do this differently. Most organizations take the severity labels and will say, okay, forget about low and medium. Let's focus on critical and high. And anything that comes up as critical and high, it's urgent that we fix those issues. So in the back of everyone's mind, I want them to think about what do they do at their organization? Do they apply or add additional context on top of that severity label, or do they take that severity label from their tools at face value and push it to the engineering team? And I think it's kind of a core question. This is a big number. We're saying 95% of all open source vulnerabilities are not reachable. We're going to get into what that means, but that's a significant chunk of all the findings that you see. Whatever product that you have today to look at open source security, it's big, right? And so just think about, what do you pass your engineering team from an open source vulnerability standpoint today?
Perfect. So now let's see as to what exactly we mean by reachable, right? So whenever your application is using any third-party libraries, and imagine they have some known CVEs. Now, for that application to be indeed vulnerable, there are many preconditions that need to be met. Now, the most core precondition to be met is there a path within your application for input that is attacker controlled, right? So any input that is coming in from the external world, is there a path for that input to reach that third party library and see whatever is happening in the middle, right? Now, if we can establish that, that is what we call as reachability. Now, on the right-hand side, we show you with our technology that we have built in-house, what we call as a code property graph. We can clearly chart all paths within an application. And what I mean by paths is not just saying, okay, hey, I see a library being loaded. Like that's the basic. But beyond that, saying, okay, this is where an input comes from. It flows from this line of code to this line of code across methods, across namespaces, and finally ends up in a library that has a known CVE. And that is what we mean by reachability.
Arun, can you unpack code property graph and data flow and kind of compare that to the last 10, 15 years? What has been happening in this space? How does that end-to-end data flow work in a CPG? Why is that meaningful? CPG being property graph.
So by code property graph, let's take what an application is. So when you write an application, let's take an example of Java as a language. An application at the end of the day is first, it's a bunch of source files, right? So .java files. So these files are lines of text. Within that, you have variables, you have methods, each method calling each other. And then you have multiple such files, and then programmers also convert them into namespaces. So, and there's code that is flowing across all of these files, methods, and code namespaces, and that what constitutes an app. Now, within the code property graph that we've built, converting that into computer science terminologies is an abstract syntax tree, a control flow, a program dependency, knowing what are sources, what are sinks, what are attacker controlled inputs. Within sinks, what are sensitive, non-sensitive. Sensitive could be files, network streams, log files, etc. So you need to know all of this context and be able to put all of that together in a single entity to understand what that application is doing. The other extreme of it could be looking at it very locally, maybe within a method, right? So within just 5 lines of code saying, hey, is something happening? Now, the analogy I use is, like looking at spelling mistakes where you can just look for one word or one sentence, to what, say, a book editor does, where he or she looks at the entire book, page to page, end to end. That is CPG versus looking for typos or spelling mistakes at a word level.
Well, because I know that on this, for the sake of simplicity, right, we're looking at a direct, an attacker controlled path going into, a specific library. But then, using this, taking this into context, an application is going to have multiple libraries, right? So there may be libraries that have vulnerabilities that are really only talking to each other and not necessarily reaching outside. And so there may be, if you're looking at that line by line kind of older method of looking at reachability, I think that's where it kind of starts going error prone, right? Because you may have multiple libraries within your application that technically have reachable vulnerabilities, but by the way the application is built, they end up not being reachable. Is that
Yeah. So
correct?
maybe let me go to the next slide and let me show you all the questions that you need to be asking to establish, is a vulnerability actually reachable and exploitable? Right. So the very basic first thing is that package actually even loaded? Now, bill of materials could have a lot of packages. These could be packages that maybe an engineer tried out at one point and then don't even use it in the code. Right. So that's that very first check. And why that is important is way back, like on slide 2, when we mentioned most SCA tools create an SBOM and then look up an existing known vulnerability database. Now, if the SBOM has packages that the application is not even using, you have noise right there. Right? So that's the loaded part. And then the second is the used part. Used part is, yes, it is loaded, but you're not actually invoking methods of those libraries right now in the code. Maybe they used to at some point, or maybe they are in paths that are never exercised in production. Maybe it's like a testing package, for instance. So is that package actually being used in production? So that's the next set of questions. And then is, okay, even if it's in use, is there a way for attacker controlled data to reach that package? Right? And then is when you need to start worrying about other known exploits for the CVE. Right? So known exploits for the CVE is, yes, there are packages with exploits, but maybe there are no known proof of concepts, no way to actually actively exploit it, unless, say, maybe you have physical access to the box, right? So those preconditions naturally eliminate those exploits for your application, which is running in prod. And then you look at what can I do to fix it, which goes back to the discussion we had of, is it upgrading the package? Maybe that upgrade is not available. Can I virtual patch it? Can I validate the input, sanitize it before it reaches the package? You can then get to those decisions. Chris or Bruce, any thoughts?
I think nothing additional on this one. I think you spelled it out.
Perfect.
Yeah, this makes a lot of sense. I think it answers the the question. I didn't mean to kind of steal your thunder a little bit on this slide, but yeah, it definitely answers kind of the direction I was looking in, where you'll have these packages that exist in the library, or sorry, in the application. And one of the things I didn't really think about until you just spelled it out is the concept of a library being used as an earlier stage, maybe like in testing or an earlier version, and then it just kind of gets forgotten, right? And isn't
Exactly.
taken out. Is that something that you
I
see
mean, we see
commonly, like
this.
in development?
Well, when we see it routinely with customers or prospects, people load a package, right? The first question on here, end up doing nothing with it, right? So traditional products or tools in this space will come out and say, hey, you loaded this package, therefore you have 10, 15 vulnerabilities. It's never even been used, or it's not being used, right? So therefore, how vulnerable is it? Certainly not reachable, because you've just basically stated the intent to use something in the future. And if you never use it, then you have to ask yourself, is there something really to fix here? And how important is it?
And the analogy, Bruce, I've heard is a lot of people compare S-bomb to a nutrition label, right? So yes, you might have bought that packet of food which maybe is not good for you, but it's sitting in your closet and you're in the pantry and you don't eat it. So then it doesn't mean it's bad for you. Yes, it is there in the house, but it's not bad for you.
It's a good way to look at it.
So yes, now we have seen what is reachability, what is exploitability, right? And let's see it from the explanation I was trying to paint a picture on, but let's see it as an image. So a simple call sequence, right, starts in A. There is an input that is coming in. There are some transformations that is happening on that data. And imagine the code, there is some conditional control flow, right? So there are three paths it can follow at that point. One goes through a sanitization function, which is D, but then ends up in an open source library, which has CVE. There is a path E that goes directly, no validation sanitization. And there is yet another path F, where that same data is used with an open source package, but that's a clean, up-to-date package, no known CVEs. And then it ends up in a sensitive sink. Now, if all you had is a bill of materials, you would just see, okay, red package, this application is vulnerable. If you had basic flow, you would see, okay, there is E going to F, going to the open source package, there is D going to the open source package. You have no context behind the scene. Now, if you have the entire context, what you can end up doing is you can eliminate the paths leading from D because it's already clean. You can eliminate the paths that are leading from F because it is a clean package. And you're also aware of all the transformations that happen in like a stage B. So that you are still aware that, yes, whatever came in from that external world in stage A is what is going through these stages. And so you need to be able to build this entire picture. The one I was mentioning about abstract syntax tree and control flow and dependency, etc., to be very like exact to say that, yes, you have these paths and hence it is reachable. But if you can do that, as we said, you could eliminate 95% of findings. Now, to give a quick idea of, like how users can experience it within the platform, right? So to start off with, if you look at the bottom is the reachability information, where it says that, yes, this CVE, what I have as a screenshot is the log4j1 with the infamous CVE, the 44228. This CVE, this package is indeed gone through all those stages that I mentioned: loaded, used, data being sent. On the bottom, it's showing there are a couple of places where there are vulnerabilities in code where it is leading into the CVE package, and the suggested mitigation steps, right? What can be done to fix it, and additional data to further prioritize this finding, right? So here we are showing that this CVE has up to 82 known exploits and hence a very high EPSS score, exploit predictability score of 0.95 on a scale of 0 to 1. So this is kind of how it is represented. And then also from a data flow perspective, giving you a clear picture of, okay, in this line, in this method, in this file, user input is being taken, and then it is flowing through your application and ending up in an open source library, so that it's proof of the reachability within your application.
I really like calling out those exploitable, like the actual exploits out in the wild, right? Because I feel like it makes it a lot more visceral, right? It's one thing to say, to for the AppSec team to pass over a list of vulnerabilities to the development team, say, hey, you have to fix all of these. But when you pass it over and say, okay, if you don't fix these three vulnerabilities, these are the exploits that are going to take advantage of that when you actually release it into the wild. And I think it really kind of makes it a lot more real and very much less abstract.
Definitely. So now we've seen, like why these vulnerabilities matter, how you can go about prioritizing it, focusing on reachability and exploitability. But now let's see, like there are way more impacts of going after everything, right? There's cost impact, time impact, and Chris does a really good job of putting that into real numbers. So let's pass it on to Chris.
All right, thanks, Arun. So we're going to look at a vulnerable Java demo app. Keep in mind, this is purposely vulnerable, and a lot of vulnerabilities were added into this. In total, there's 160 open source vulnerabilities, right? And so we were talking earlier about what do organizations do today in terms of what is their path to fixing? How do they present this information to engineering? The first path is typically one of two ways people go about this, right? You have a security intensive path. That means you gather all of the vulnerability information and you conduct analysis by your own application security team. You pour through the data, you try to figure out on your own what is actually reachable, what exploits are out in the wild, how do I prioritize this so I could send high signal to engineering teams. Typically, this is, I actually don't see this a lot in organizations. This has a tendency to be reserved for organizations with scaled security teams with large product and application security functions within that team. It takes a lot of human effort, right? And they send prioritized results to dev teams, right? So it's on one hand, you are investing in the human capital to be able to do this analysis on behalf of the developers before passing it to them. The second path, which I think is, from my experience, a lot more common, and we see this a lot of times with our customers, at least early on in our engagements, is they send results directly to the development team and ask them to fix it without context, right? And so if you send vulnerabilities, even if you minimize them down to just high and critical, without additional context, the developers have to stop building whatever it is they're building. They themselves have to start performing an analysis. And so I think everyone knows the space and application security over the last 10 to 15 years has been riddled by false positives. And so the engineers have to actually go look at these types of things. Then, depending on how skilled they are or how in tune they are with the security vulnerability landscape, they themselves might be trying to figure out, well, hey, I loaded this package, I know that, but did I ever use it to determine kind of their own view of reachability? Both of these cases have significant downsides. Path one, you invest a lot of time, money, and resources in human analysis by the security team. Security team tends to be a hell of a lot smaller than the dev teams themselves. And then the path two, the dev teams, like I said, stop building their products. They stop focusing on what it is they're doing to build features and drive revenue. And instead they have to triage, they have to look, they have to figure out what they actually need to do and go fix them without the context. So we can jump to the next page. So we have a basic cost calculator. You can kind of mess around with this with your own applications and own team. But I used it just as an example. In our demo app, of the 160 vulnerabilities that were produced, there's a total of 114 high and critical vulnerabilities. All right. And so I used some pretty conservative estimates of the amount of time it takes. It could be higher, it could be lower, but just for example's sake, $150,000 a year for cost of a developer. It takes about 4 hours to evaluate a vulnerability. That's the full triage, the full analysis, and that's the time spent actually fixing it in the code. On the right side of the page, we just talk about, well, how does that translate into hard dollars? And in this case, it's just shy of $33,000 and 456 hours spent on the application to fix the vulnerabilities presented. And keep in mind, that's taking all the highs and criticals. That's what most people are doing to actually downsize the amount of vulnerabilities that go to the development team and engineering teams. Okay, so instead of just thinking about the world from a severity perspective and taking those highs and criticals, this is the recommended approach that we suggest to people when they start thinking about how do we really mature our program as it relates to open source vulnerabilities. On the left side, most people aspire to have build system integration at this point, right? If you're not doing that, you obviously should be. But we're getting to a point now where SAST, SCA, open source security, a lot of this stuff is actually happening within, and it's fully automated within the build system. So nothing new there. The second piece is you have to start deciding, are you going to have a tool, a technology, team of people, whatever it is, you have to enrich the information that you're getting from your tech stack. And it can't just be the severity levels. So in the case of our demo app, it starts at 160. We want to focus on something more, additional context, higher signal. So we implement the reachability feature, right? You go from having 160 total vulnerabilities across all severities to 46 total open source reachable issues. And that's critical all the way to low. Within that 46 is a subset of 7 that have exploits, right? So they're easily exploited. They're potentially being exploited in the wild, part of an active campaign, or there's some example source code out there that would help you actually execute the exploit. This is the context that we're talking about or have been talking about throughout the presentation today. This is what helps your engineers actually focus on what matters. The 46 vulnerabilities that are reachable, that from a risk perspective is what you should be focused on, right? So if you follow the flow from 1 to 5 here, you go through, you filter out all the reachable issues, you bring those in, you understand exploitability that gets you to 7. All the remaining vulnerabilities outside the 46, there's no pathway to exploitation, right? And so when there's no pathway, it's safe to put them in a backlog. And that's how we thought about it on the right side of this page. Priority 1 has to be your reachable and exploitable. And we always recommend you should do those in the very next sprint to the extent that you can, right? Because they're the easiest to actually compromise an organization with. We know that there's an attack path. We know there's exploit code out there. Fix it as priority 1. I always like to say priority 2 is reachable, and to the extent that you can fix those next sprint as well. I would argue, and I think this is a very important point, when you have a reachable vulnerability of medium severity, I look at this as a higher risk issue than a critical severity vulnerability that has no reachable path. So it's a really important point that I want to make, is that if you're not doing this reachability analysis, you're spending a lot of time, a lot of cycles, and it turns into cold hard cash. A lot of money is being spent on things that there's no path to, right? And then, like I said, the priority 3 is all of the unreachable issues that are tech debt. And notice that I don't say simply don't fix them. That's a choice that the organization can make. The reality is you might have displayed your intent to use a package, not use it, but it's possible that someone could call on it and use it within their code. So it's got to be accounted for. It's just a matter of when you actually address it. Bruce, Arun, comments, questions on this?
Yeah, it's interesting because it really does become this kind of triage method, right? Of figuring out what, and almost like that 80-20 rule, right? Like, what are the ones that are going to be the 80% of the risk? What are the ones that I need to focus on first, right? And I think it's important too that we do, and I know you've said it, but I want to kind of reiterate that, those 160 that are still left over, they still need to be dealt with at some point, right? Because it's just good security practices to be able to, reduce, the amount of potential vulnerabilities. Because just because something isn't reachable today, maybe there's a new update to your application and then it becomes reachable, right? And so having those things hang out there are still something you want to take care of. But it is really, I like that focusing on that 7 reachable and exploitable. That's an easier and more attainable goal, right? And I think from, for security teams and for development teams, you always want to have those metrics of improvement, right? You want to be able to have something that you can say, look, over the past 2 weeks, we improved by 23% or whatever, because we fixed these, and these, and reduce risk by X. And I think it's important to know really where to focus those efforts to get the biggest bang.
Yeah. And before we get into the numbers here, I think the other thing that I'd say is that when you start thinking about your vulnerabilities in this way, I think it drives a much better relationship between engineering and security, because the information coming over in the JIRA tickets, into the sprints, these are things that you need to fix. And it's easy to kind of coalesce around them to gain agreement between both application security and engineering that, yes, this is indeed, when we say something is of high risk, or when we say something is critical, we mean it, and it can be relied upon as real.
Yeah, and I think it also flips the head on taking an outside-in approach and changing it to an inside-out approach, right? Because outside-in is saying, hey, this is critical because like the National Vulnerability Database says so, versus, hey, what actually matters for my organization? Let's focus on those first. Yeah, so I think that also plays to the organization's risk profile, as you rightly point out.
Just again, when you focus on fixing reachable vulnerabilities, which would be the 46 from our example previously, it's a significant cash savings, significant hours savings, right? We talked about that third bucket, which is backlog. And again, we're not saying don't fix those, but when it comes to making the risk choice about whether or not you fix them now, later, or at all, that remains up to each organization's risk profile and kind of how they operate. But if you look at the savings, I mean, it's apparent. We'll see that on the next page when we get into the final details. So what, right? This is what we want to leave everyone with, right? When we think about the way we're building our product, when we think about the way we run our internal AppSec team, everything that we do is risk oriented, right? We want to prioritize the findings that we get that are the highest impact, and we know that there's actually a path to an attacker can take to exploit a vulnerability, right? And in our case, we've addressed 46 high-risk vulnerabilities based on that reachability and exploitability factor, and we're tabling the other issues until a later date. Probably more importantly is when it comes to security teams being good partners with engineering, which is really what supercharges your AppSec program. A lot of what we're doing, and a lot of our core value, is enabling speed, enabling velocity. And so this example that we've looked at is really what helps you enable product velocity. It helps you be part of the solution and not a barrier. In this example, we reduced vulnerabilities by 68 of the total, right? The amount of time spent came down by 65%. We saved 295 hours that your developers and your engineers could have been spent on building new product features that drive revenue. At the end of the day, if you're a security team, you come to the table by supporting and enabling product velocity, that's when you know that your AppSec program's on the right track. So ultimately, what does that come down to? It comes down to going above and beyond severity labels, getting into reachability, getting into exploitability, and really providing high signal, eliminating noise.
And I think that's a great point, Chris, because I think a lot of the friction that you run into is that, you've got the AppSec team providing far too many fixes for the app team, right? For the development team. And what you really want to build, if you want to build that culture of security and that kind of, you want those teams working together. And so you want, from an AppSec side, you want to know that whenever you send something over, it's going to be listened to and paid attention to. And then from the development side, it's kind of the reverse. You want to know that if any email or any alert you get, through whatever ticketing system or whatever from the AppSec team is important. And then you're going to pay attention to it. And that's the only way you can really kind of improve your program, is by having both teams working together and really trusting each other that they're doing the most to kind of maximize these issues that come up, right? And maximize the fixes.
Yeah, when I was at Nielsen, Clay Carter and his team did a really good job of basically aligning with the engineering teams on creating guardrails. What are the guardrails that the engineering teams can operate within without ever having to engage security, right? And typically that would be, don't produce a reachable vulnerability. If you do, okay, let's talk about it. We don't want you going to production with you with that vulnerability, but let's talk about it. So we tried to empower engineers to completely operate independently, own their own destiny. And when they deviated from the guardrails, that's where the application security team had to come into play. We tried iterations prior to that were a lot more complex. So went back to those other examples that I brought to the table about the path, right? A heavy security path versus a heavy developer path. And we struggled a lot more mightily with those. It was when we focused on developer empowerment, context enrichment, signal elimination and noise, that's when we started running 100 miles an hour.
I do want to give, our guest here, kind of a closing argument. Like if there's anything that you want to really close in on to kind of finish this out that, think the audience will get some good benefit out of. So Arun, I'll go ahead and start with you on that.
Thanks, Bruce. And again, thanks for all the questions and all the engagement from the audience. Closing thoughts, I would say, look at what you do today, your processes, see if you're able to achieve this level of prioritization of the findings you have, right? All the organizations we speak to have this issue of noise and a lot of findings. And see if what you have today in your tooling can help you achieve reachability, exploitability, help you bring down findings so that you fix what matters versus fix what some team tells you needs to be fixed.
Chris, anything you want to share?
Yeah, like Arun said, thank you for the engagement, the questions. This is a lot of fun. This is a subject I'm really passionate about because, like I said earlier, I've gone through kind of the fits and starts of different AppSec programs and the build outs. I'll just reiterate, saw most success when we started to more closely collaborate with engineering and focus on the developer experience, right? The developer experience matters a lot because at the end of the day, security teams exist to align risk with risk appetite. And really, it's about how do you best facilitate velocity in the engineering cycles, right? That's what you want to do. You want to enable that speed with low risk. And to the extent that you can get the engineering teams to ally with you on that journey, you're going to have so much more success. So just think through how you can enable your dev teams, think through how you build a more solid relationship. And a lot of that comes down to high context signal, low noise.
Great, thank you. So I do want to thank you guys for stepping in. This has been really informative. I've learned quite a bit as well, and I want to, of course, thank the audience for tuning in. Hope you got a lot of value out of this. I would ask that you keep an eye out because we're going to be having a lot more webinars being released in the short future with a little bit, a lot more in depth and technical and organizational type of discussions. So thank you again for tuning in. And my name is Bruce Snell with Qwiet AI, and have a great day.
Just a quick plug: we're doing an awesome party at Black Hat. Go to our website, sign up. It's going to be great.